So I'm here today with my colleague, Kayla Mathis, and we're going to talk to you about some work and some thinking that we're doing around protecting carbon permafrost using fire management. We come from the Colorado Research Center associated with Permafrost Pathways Project. It's really appreciated the opportunity to be here. All right, so I'm not going to spend much time on this slide, just discussed that one yesterday. We just want to note, again, we're seeing intensifying fire regime. We're seeing, in general, because of more severe fire weather, longer fire seasons, and actually more likely efficient kind of one. The graphs on the right are from Northwest Territories, was large years, 2014, 2023. There are different carbon numbers out there, but those years roughly 200 to 300 times the emissions from all other anthropogenic sectors at UT. So massive play of game. These patterns are happening across the Arctic oil region, including Alaska, and that's where we focus most of our work to date. We've had the best sort of data and context there, but I think the lessons learned from what we're doing in Alaska could potentially apply to NWT. So on the left is a map of Alaska showing what are called fire management zones, and I think this is pretty similar to how a lot of the fire management operates in provinces, territories, Canada. Most of the state of Alaska is in that green limited category, meaning the fires are just sort of monitored, but nothing's sort of done. There's small amounts of red around cities and communities are areas the fires are just put out, all fires are put out, and then full and modified are kind of somewhere in between. A lot of the cases, it's fires being steered away the values over us. So we looked at this data in a lot of different ways, including machine learning, and to ask the first question, which is how effective has historical fire management here, fire suppression, been at limiting fire size? In the middle is a graph for that. It's a relatively simple way to look at it, but again, we do look at this in many different ways. It's a log plot, so small differences on the y-axis, we large differences in reality, and you can see the fire size decreases with more actively. So what we did is we took that together with cost data from the Alaska Fire Service, worked with economists and an econometric model, and then coupled that together with sort of the effectiveness of historical fire suppression to limit the fire size, together with carbon data we had and carbon emissions, and come up with the graph on the right, which is if you were to think about historical fire suppression in Alaska as keeping carbon in the ground, it would cost about $13 per ton of CO2 to do so. That's a central estimate. Of course, there's a big range that goes up to over E. So there's, this analysis is not perfect. In a lot of ways, it actually could be conservative, in part because historical fire management is not done to limit fire size or to keep carbon in the ground. We also only looked at CO2, not methane or other warming gases forming for fires. And we also did not incorporate permafrost into this analysis. But permafrost is really important. As we all are talking about here today and yesterday, in Alaska, there is a lot of permafrost called Gedema permafrost, which listen probably know about. The Kudotsu Dome Gedema is Pleistocene age, silty permafrost, often very deep, formed in unglaciated regions, often has high ice and carbon content. So the map on the right is showing a distribution of Gedema permafrost in Alaska. It's about 20% of circumpolar Gedema. The rest is in Siberia. And a photo on the left of what can happen when you have a fire. Easy Gedema systems, a severe fire can lead to subsidence and thermokarst activity and sustained carbon emissions over time. And although Canada doesn't have really much Gedema at all, there's a lot of people in the movie they're talking about. So I think they use sort of the analogy you really keep in some. So, we started this work a number of years ago, communicating and working with different fire managers and management agencies in Alaska, and it resulted in a really sort of unprecedented management project in the Yukon Flats National Wildlife Refuge of Alaska about 2 years ago now. And so what you're seeing is a map of the Yukon Flats. It's about 3.5 million hectares in total. The inset on the bottom right shows you where it is, sort of eastern interior Alaska. Mostly fish and wildlife land, but there are communities and private land within the refuge. And so they decided to enact this for the first time in the U.S. to use fire management with a carbon lens to protect carbon, in this case permafrost. So all the Gedema is shown in green. The protected Gedema is in darker green. It's about 700,000 hectares or so. And the whole idea is the Alaska Fire Service will come in, and there's protocols around it. It's sort of a pilot project case study. So they will go after the fires if they can confidently do so using aggressive initial attack. If the tech can suppress those fires in 72 hours, and there are not other sort of higher values at risk elsewhere. Also, I would just mention this was done, I think anytime we're thinking about fire management or land management, there's all kinds of decisions you seem to be included to make these kind of decisions. So it was motivated by carbon and permafrost, but also, this region has been seeing a lot of fires in the last 3 decades, more than sort of the paleo record. Communities in the region, when they voicing their concerns over smoke, which is a hell hazard, but also impacting subsistence and travel, and they've just been losing mid to old growth habitat. So it's kind of convergence of values that is surrounding this decision, and we're hoping to learn from it. So we're working with Fish and Wildlife to sort of understand the needs and effectiveness of this approach, and sort of think about the other values at risk, the other co-benefits of this site approach, and how it might be merged with other techniques on the ground, supposed prescribed by our cultural burning, Jules treatments, etc. So I'm going to pass them up to Kayla. She'll describe our work, and I'll come back at the very.
Hi, everyone. But yeah, I'm going to talk a little bit more about our work associated with this pilot project, and then think into the future and how we hope to expand beyond the pilot project. So as Brendan mentioned, over the next few years, our Woodwell team is working with the U.S. Fish and Wildlife to execute this research objective, which is to estimate unweighted the carbon emissions from targeted fire suppression on the Yukon Flats National Wildlife Refuge and quantify the cost effectiveness as a potential plant mitigation strategy. So ideally, they would be carrying out this objective on fires that occur within the pilot project, but fires don't occur in this designation every year. And so to continue working on this project, as well as think of the broader applicability of this type of work, they built up an historical fire data set that draws from fires across the state of Alaska that were also on land underlain with permafrost. And the goal is to find fires that would be similar to fires that occur within the pilot project, both in terms of ecosystem characteristics and, importantly, how the fires were managed and suppressed. So with this data set, I'm going to just kind of briefly walk through our research framework. This work is still being underway, so I don't have results to share with you, but for methods. So the first question we're asking is, how big would these fires have been without suppression? So we are going to be using retrospective fire behavior models, specifically working with Abyss Pro and Farsight. You guys are familiar with those. But basically, we're going to be modeling these counterfactual fire spreads or burned areas, so how much these fires would have spread had suppression action not been taken. And with those burned areas, or counterfactual burned area, you will ask how much carbon was protected, or how much carbon would have been lost had these fires not been suppressed. So in quantifying these avoided carbon emissions, we're going to look at both the combustions, or loss of carbon from combustion of the fires, as well as carbon lost from post-fire permafrost thaw, which is much more complex, but a really important piece of this puzzle. And then finally, we will ask how much they cost. So we will be estimating the costs of these fire suppression efforts on historical fires on permafrost. And then we're going to get at this cost per ton of avoided carbon emissions. And from there, we can compare these costs to other emission reduction methods to quantify how cost-effective protecting carbon and permafrost with fire management is as the quantification strategy. So Brendan touched on this a little bit, but the pilot project of the Flats wasn't just motivated by rejecting carbon and permafrost, but by the growing understanding that the intensifying fire regime in the Yukon Flats region is also increasing wildfire smoke, indigenous food security, subsistence activities, and air travel, which is essential in this region. And so our team, in addition to thinking about how to protect carbon and permafrost, are committed to building processes by which this kind of expanded set of converging values at risk could become explicit priorities in fire management in Alaska. And a couple ways that we're working on this, it's we're building a relationship with a tribal organization on the Yukon Flats called the Council of Athabasca Tribal Governments to better understand indigenous fire stewardship needs that are not being met at the state level. And from there, we can use our agency as scientists to advocate for these needs in policy spaces, as well as advocate for cultural burning as essential components of management systems. And we're also collaborating with experts at the University of Alaska who are building a smoke and human health specific dimension to fire management policy in Alaska. And I want to take a step back because we've been hearing some really valuable knowledge about the importance of fire on the landscape, particularly and elders in the room, and this understanding that suppression is not and should not be our only way of thinking about fire management. And while this project uses suppression, I want to emphasize that these parallel management strategies like cultural burning, fuels treatment, prescribed burning are complementary and vital to this work in order to promote ecosystem and cultural lanes and being good fire on the landscape. So as we're committed to advocating for kind of a diverse set of fire management strategies as we carry this work forward. And so now I want to talk a little bit about some tools that we hope to help expand here on the pilot podium. So we're in an effort to build a carbon vulnerability map, which identifies areas of high carbon emission potentials coupled with high fire risk across the Alaskan and Canadian boreal. And we've heard directly from fire managers in Alaska that this is urgently needed to serve as an operational tool as carbon and permafrost are growing in prominence in fire management spaces. And so these maps, as Brennan showed, the one on the left, are kind of the general outline of the suppression zones in Alaska and Canada. So a goal here would be to use these maps as a tool to help inform future versions of suppression zones and identify areas where protecting carbon and permafrost with fire management would be both appropriate and the most impactful. So now I'm going to turn our attention to the Northwest Territories. You've seen versions of these maps for the last day, but again, this is the permafrost extent of the Northwest Territories, and then it's, we've mentioned before, most of the region is underlain with continuous or discontinuous permafrost. And then here is a map showing modeled soil organic carbon from permafrost-affected peatlands and the NWT. And as we've been talking about the last 24 hours, there's a lot of carbon in East peatland ecosystems. This map also outlines the different Taiga sub-ecoregions just to highlight that a lot of this carbon in these peatland ecosystems is concentrated in Taiga Plains region, which is in the dotted line. We also know that wildfires are increasing the climate change in these boreal peatland ecosystems, and this is increasing the amount of fire-induced permafrost stock, and this has, is threatening persistence of this deepland carbon, and you talked about this a lot. And this study that I highlight here was regionally focused in the NWT near Delta. So this pilot project that we've been talking about is focused in Alaska and on Yetama permafrost, and this is all on Yetama in Canada, but we are really motivated and interested in building collaborations with folks in NWT, land managers, community members, scientists who might be interested in considering how fire management could be used to protect this carbon and permafrost in these boreal ecosystems. And we think that the Taiga Plains would be an interesting area of focus, but we are not experts on the NWT ecosystems or the complexities of the fire management ecosystem or communities' values. So we're really excited to be here and we're from you all and to continue hearing their perspectives on it. So I'm going to pass it back to Brendan very quickly to give us some final thoughts.
Yeah, thanks, Kayla. Okay, so this is a really tricky and complex space, and I'm sure there's a lot of opinions in the room that I've all years that talk to you all and hear those opinions. But I want to end with some just key considerations about this work and as informed our evolving thinking. So just starting with our analysis shows, and Kayla described the current project, that boreal fire suppression for carbon protection appears to be a viable, potentially cost-effective natural climate solution. One thing to note is, we really need to stress, this is only viable in the context of deep reductions of fossil fuel emissions. This is not a silver bullet. It's not to save us. There was a comment yesterday about potentially being a Band-Aid. I might kind of agree, but I think at this point, we need to consider Band-Aids. While we also interested, we probably just global fossil fuel issues. I think I mentioned a couple of reasons why are using fire management as a tool to affect carbon permafrost might actually be more cost effective than our analysis indicates to date, because it's based on historical view that was not, fire management was not used for that purpose. Okay, so this is probably one of my most important points, right? So we are by no means in any context talking about suppressing all fires. We know that that is a bad reason. There's a lot of data, knowledge showing that fires in central part of the ecosystem. So anytime we're talking about this expanded fire suppression, it's in the context of the much elevated fire regime that you're experiencing right now. And we would never sort of suggest and going below what's called ecologically appropriate levels of fire, which is context dependent. Related to that, as Kayla mentioned, we need to sort of think about all the tools in our toolbox, right? Talking about prescribed fire, talking about cultural burning, fuels treatments, some level of living with fire, community protection. I would just say that, targeted suppression, I think, should be in that toolbox. And also, we're not talking about spending millions of dollars in the large fires that were spreading rapidly in severe fire weather conditions. We're talking about using emergent technology. There are people out there, people looking at like drones and UAVs. There's people looking at like just suppressing lightning, looking at targeted, cost-effective, going after fire right after they start. Because the costs go up exponential or your weight. Fires and ecosystems affect a lot of different people a lot of different ways. We need to account for all ecosystem services, land uses, and indigenous sovereignty. We can't think of this problem myopically just looking at permanent permafrost, right? There's a lot of different uses, a lot of different needs around these lands. And so what we're trying to do in Alaska is to think through, what are solutions that can address all of these. The reality is that any sort of implementation of this will require significant additional resources. I just want to say that, there are multiple potential sources of those resources. I know that some of the conversation in this meeting is going to sort of go in the direction of carbon markets. That is not something that we are experts on. We would just say two messages from our team. One is that we would just really stress the importance for robust accounting standards, and not only with fire management states, but any of these natural fire solutions, to make sure that issues such as permanence, additionality, and leakage are robustly accounted for. And we also sort of believe that really this should be done in the context of companies that are committed to decarbonization. Otherwise, just to sort of the Vegas to address as hard to evade fossil fuel. So applicability to Northwest territories. Permafrost and peatlands and NWT store large carbon stores and are increasingly threatened by wildfires, largely climate change. Wildfire management could be a cost-effective approach for preserving some of that and has potential benefits. People, and as Kale mentioned, we're seeking opportunities to collaborate in order to remove all the dismay or the non-mixes and in this. But, I think